Chapter 2. The Big Bang and the Seed of Creation. What is cosmic potential and where did it come from? Let us now examine the evidence pointing toward a creation event. Evidence that, if taken seriously, strongly suggests the involvement of an intelligent source. Consider a question that seems simple at first glance, yet carries extraordinary weight. Did the universe emerge by sheer chance, or was it purposefully created? The question is deceptively straightforward, but its implications challenge our deepest assumptions about reality and our place within it. This single inquiry draws us into some of the deepest mysteries of cosmology, physics, and metaphysics. When we attempt to explore it scientifically, without appealing to religious dogma or pre-established belief systems, we find that a surprising pattern emerges. The evidence increasingly points not toward randomness, but toward an underlying order, structure, and intentionality woven into the fabric of the cosmos. Modern science has delivered an astonishing wealth of insights into how the universe began, and many of these insights are not easily reconciled with the notion of a purely accidental origin. At the center of this story is the Big Bang. According to decades of astronomical observations and cosmological modeling, the universe began approximately 13.8 billion years ago in an unimaginably dense and hot state, commonly referred to as a singularity. This singularity is not merely a convenient theoretical construct. It arises as the natural conclusion of tracing the universe's continual expansion backward in time. As we extrapolate this expansion, all matter, energy, space, and even the fabric of space-time itself converge toward a point where our current mathematical models and known laws of physics effectively break down. The concept of the singularity is profoundly significant because it represents the boundary at which classical physics fails and a deeper explanatory framework becomes necessary. Within this infinitesimal state, densities and temperatures reach extremes that make our current theories, general relativity and quantum mechanics, mutually incompatible. In other words, the singularity marks not just the beginning of the universe, but also the limit of human scientific understanding. Its existence suggests that whatever initiated the universe lies beyond the mechanisms we can currently describe, raising fundamental questions about causation, origins, and the possibility of an intentional creative act. From this initial point, space, time, energy, matter, and the fundamental laws themselves unfolded. This expansion was first discovered by Edwin Hubble in the 1920s. By examining the light from distant galaxies, Hubble found that the farther away a galaxy is, the faster it appears to be moving from us. This observation revealed that space itself is stretching, a discovery that overturned centuries of assumption that the universe was static and unchanging. If the cosmos is expanding now, then at some time in the distant past, everything must have been compressed together. This reasoning forms one of the foundations of the Big Bang model. Modern telescopes, including space-based observatories, have confirmed Hubble's findings with extraordinary precision, mapping out the expansion of space across incomprehensible distances. Additional confirmation comes from the cosmic microwave background, the CMB, the faint afterglow of the early universe. In 1964, scientists detected this radiation accidentally. What they discovered was the thermal signature of the universe when it was only about 380,000 years old, after it cooled enough for atoms to form and light to travel freely. This background radiation blankets the universe uniformly, yet contains subtle temperature variations. These minuscule fluctuations reflect the first density variations that later grew into galaxies, stars, and planets. The CMB not only matches theoretical predictions, but does so with such remarkable fidelity that it has become one of the most powerful pieces of evidence for the Big Bang. Its existence, structure, and characteristics point toward an ordered beginning rather than a chaotic or random one. The theory of Big Bang nucleosynthesis deepens this picture. In the first minutes after the universe began, temperatures were high enough for nuclear reactions to occur, creating the lightest elements, hydrogen, helium, and small amounts of lithium. The predicted proportions of these elements, based on known physical laws, match observations with extraordinary precision. This remarkable alignment between prediction and observation strongly suggests that the early universe operated according to stable, finely balanced laws. The universe's large-scale structure provides yet another layer of evidence for underlying order. Galaxies are not scattered haphazardly throughout space. Instead, they form an intricate, web-like structure composed of filaments, clusters, and vast cosmic voids. This pattern emerged from initial quantum fluctuations in the universe's earliest moments. The existence of such a structure indicates that the universe did not evolve arbitrarily. From the earliest fraction of a second, it possessed precisely the right initial conditions to give rise to the ordered complexity we now see. Then there is the discovery that the universe's expansion is accelerating, driven by a mysterious phenomenon known as dark energy. This acceleration was revealed in the late 1990s through the study of distant supernovae. The fact that this acceleration is neither too strong nor too weak is striking. If it had been slightly different, galaxies would never have formed, stars would not ignite, and life could not possibly arise. The delicate balance of cosmic expansion, gravity, and dark energy suggests a finely tuned system operating within narrow parameters. So much so that, as astrophysicist George Ellis notes, the realization of the complexity involved makes it very difficult not to use the word miraculous. This observation underscores just how extraordinary the harmony of the universe truly is, hinting at a cosmos uniquely poised to allow life to emerge. The strength of gravity, the mass of elementary particles, the charge of the electron, the ratios of the forces, and the value of the cosmological constant all fall within extraordinarily precise ranges. Even slight deviations in any one of these constants would produce a universe that collapses instantly or expands too rapidly for structure to emerge. The improbability of these constants aligning by chance is so great that many scientists compare it to throwing darts blindfolded across the universe and hitting the same precise point every time. A helpful analogy is the DNA molecule. DNA contains encoded instructions capable of generating complex life through the arrangement of its nucleotides. In a similar way, the constants of physics seem to form a kind of cosmic code, governing the formation of atoms, stars, galaxies, and eventually living organisms. Quantum mechanics adds even more layers to this mystery. At the subatomic scale, particles exist in probabilistic states rather than in fixed positions. Quantum mechanics suggests that observation, meaning a physical interaction or measurement that creates a record, helps determine a particle's state. The rules of quantum behavior are astonishingly precise. These rules allow quantum fluctuations to seed cosmic structure, allow atoms to form stable configurations, and allow the universe to produce complex molecules, including those necessary for life. The quantum world is not chaotic. It operates according to subtle, elegant, but deeply unintuitive rules. This precision suggests underlying order far more than randomness. In response to the problem of fine-tuning, some physicists have proposed the multiverse hypothesis, the idea that our universe is only one of countless universes, each with different constants. While this hypothesis is intriguing, it raises further questions. What mechanism generates these universes? What laws govern the multiverse itself? And how did those laws come to be? Invoking an infinite number of universes does not eliminate the need for an explanation of the order and potential within the overarching system. This brings us back to the singularity. The singularity was not simply raw, featureless energy. It was a concentrated point that contained the laws, constants, and potential that would shape the cosmos. From this point, the universe unfolded with extraordinary precision. The existence of such potential implies a cause capable of producing it. Nothing in our experience suggests that order, laws, or potential simply arise spontaneously from absolute nothingness. Philosophically, the question becomes one of ultimate causation. Science is powerful in explaining how the universe evolves from given starting conditions, but it does not and cannot explain why those starting conditions exist. If the universe displays order, coherence, and intelligibility, it is reasonable to consider the possibility that these characteristics reflect an intelligent origin. This conclusion does not affirm any religious narrative, it simply acknowledges the implications of the evidence. Some modern thinkers, inspired by advances in computing, have proposed the simulation hypothesis, the idea that our universe might be a simulation created by a higher-level intelligence. While unproven at this time, it offers a striking perspective on intelligent design, showing that the universe's remarkable precision need not point to traditional theology. Personally, I am inclined toward this view, not only because of the delicate balance of cosmic forces and the emergence of life, but also because of the astonishing facts revealed by quantum reality, the strange, counterintuitive behavior of matter and energy at the smallest scales. Taken together, these phenomena suggest a universe structured with extraordinary care. The simulation hypothesis invites us to entertain the possibility that intelligence underlies the cosmos in ways both profound and mysterious. It is a recognition that the universe behaves in ways suggestive of information processing, mathematical structure, and intentional parameters. Quantum mechanics, with its discrete energy states and digital-like behavior, adds to the intrigue. Even if, for now, we set aside the simulation idea, the universe itself displays unmistakable order. Physical laws are mathematically precise and stable across time and space. Stellar evolution follows predictable patterns. Chemical reactions behave consistently. Life arises under conditions so specific that the coincidence of conditions occurring without guidance appears extraordinarily unlikely. Einstein and many other great scientists marveled at this mathematical coherence, seeing in it something akin to a deeper rationality. Biology further reinforces this theme. DNA is a code, not merely a chemical chain. Evolution explains adaptation and diversification, but does not address why the universe has the exact conditions needed for chemistry, complexity, and life to exist. For evolution to operate at all, the universe must already be finely tuned. Finally, the emergence of consciousness is perhaps the most striking evidence of all. In a universe that could have been sterile, lifeless, or chaotic, conscious beings arise, capable of curiosity, reasoning, creativity, morality, and wonder. When we consider all these elements together, the Big Bang, the CMB, nucleosynthesis, cosmic structure, dark energy, fine-tuning, quantum mechanics, biological information, and consciousness, a coherent picture emerges. The evidence does not point to randomness. It points toward intention. It points toward order. It points toward a universe whose origin and structure appear aligned with deliberate creation. Rejecting this conclusion requires assuming that an extraordinary series of improbable events occurred without cause, direction, or purpose. While science cannot yet identify the ultimate source, the inference from the evidence is strong. The universe's origin and design are far more consistent with a deliberate cause than with blind chance. Even if the nature of this cause remains beyond our full comprehension, the universe invites us to recognize its remarkable precision. From the singularity's potential to the emergence of galaxies, stars, and conscious beings, the cosmos reflects an underlying structure that is mathematically elegant and deeply meaningful. In contemplating these discoveries, we are reminded that the universe is not random matter drifting through space, but a coherent, intelligible system. The universe challenges us to consider that behind all existence lies a deliberate origin, scientifically grounded, rationally sound, and profoundly compelling. All that we see and all that we are trace their lineage back to what emerged at that singular beginning, the Big Bang event.